Hi, this is the explanation of principle of light controller. How does it work? First example, we want to control proportional LED, so we need to control the brightness of those LED, and we will use throttle to control the brightness. So moving the throttle from minimum to maximum will result in controlling the bright of LED. How to do it with Arduino? Quite simple. We will read pulse from receiver. So parameters of pulses are from 1000 microsecond to 2000 microsecond. And we will map this value into 0 to 255. Why? Because in Arduino, analog write means that with analog write 0 LED is off, and analog write 255 means LED is on maximum bright. How to do it? How to make this mix in HTX or OpenTX? This is example of mix. We will have our examples of channel 6. So this line minus 100% of weight means that we will begin from this point. This is our point 0, minus 100% in OpenTX of HTX. And we will take throttle with this weight and this offset. Why this offset? Because we need to be in the middle of this range. So this is our point 0. We will add to this point plus 100%. So we are going to here, and throttle has weight minus to plus 97%. So the throttle, when I will go in from minimum to maximum, it will result in output from, and I use this interval 3%. So it will go from minus 97% to plus 97%. Okay? So this is the mix. And how does it work? When we go into channel monitor, on channel 6, we can see now that we are at minus 97%. So we are here, minus 97%. And when I will move throttle stick, we are going to maximum 97%. Yes? So this is our mix in transmitter. And now, how we will decode this with Arduino? Quite simple. We will use command map, and this is our example in Arduino. We will read value from receiver, this line, and we will map this value. And look, here we are from 1025 microseconds to 1975. Why? Because I choose 25 microseconds in this example, that is this value, this 3%, that is not exactly that value. It's in real life is I think 15 microseconds, but to demonstrate it with servo tester, 15 microseconds is very low. So for this Arduino example, I will use 25 microseconds. So we will map value from this to this into 0 to 255, and I will write it with command analog write into output pin. So how will this work with servo tester? Okay, so we have a simple servo tester, and now we will use JET1 for our demonstration purpose as proportional LED. And now we are going from 1000 microsecond with servo tester into 2000 microsecond. And what will do proportional LED, our Z1? It will go from minimum to maximum. Let's try it. So now I'm going from minimum, and it's on to maximum. Yes, this is maximum bright, and we are going to minimum bright. So we can control with servo tester, in this example, brightness of Z1 LED. Easy? Easy, no problem. Okay, and now we want to control not only proportional LED, but we want also control cabin backlight two-state LED. So we want to have one switch, and with this switch we will turn on and off cabin LED backlight. And as in previous example with throttle, we will control proportional LED on jet. How to do it? Quite simple. We will divide this range into two parts. Yes? And we will use switch SC to control two-state LED, and it will have weight 100%. So with switch SC, we are switching from this point to this point. It has weight 100%. And throttle, proportional LED, will have weight not 97% as this was here, and offset 100%, but we will divide it also by 2, so we will have offset 50%, and weight we will have 47% plus minus. So the throttle will go from here to here when switch SC is off, and it will go from here to here, so from 3% to 97% if SC is on. Let's check it if it is true. We will use this mix. And again, this is our point 0, weight minus 100%, so we are here in this point. And now this is switch SC. It has weight 100%. And the previous line, so we will add these two values together, is throttle, and it is weight 47% and offset 50%. How does this work? So when switch SC is off, we will be here in this range. So throttle will go from minus 97% to minus 3%. Let's check it. We will run channel monitor, and now switch SC is off, it's in default position, and now our output value is minus 97%. It's here. And with throttle now I will go from minus 97% to minus 3%. So let's go. Now it is minus 97, and we will go up to minus 3. Okay, that's fine. And now we will switch SC place into mid position, a non-default position, and look what happens. Throttle, our output signal go from minus 97 to 3%. Why? Because this map says that we are jumping from this position to this position. So now SC is on, and throttle will go from 3% to 97%. So when the switch SC is in a non-default position, with throttle now we will go from 3% to 97%. Okay, and how we will decode this LED map with Arduino? Quite simple. The first we will test in Arduino is the input signal more than 1500 microseconds? If yes, we will switch on cabin LED. And if it is more than 1500, we will subtract 500 microseconds. Why? Because this range is 500 microseconds. So we need to go from this range here, and after we will decode in the same way as we do here, proportional LED. This is an example in Arduino. We are reading value from receiver, and now if the value from receiver is higher than 1500, we will turn on cabin backlight LED, otherwise we will turn it off, and we will subtract 500 microseconds. And in second step in Arduino, we will map input value, and please note that now we are going from 1025 microseconds to 1475. Why? Because, as I told before, I'm using in this Arduino example this range 25 microseconds. So we need to decode range from here to here. So this is 1025 microseconds, and this point here, not here, here, it's 1500 minus 25 microseconds, so it's 1475. So we are mapping this range again into 0 to 255 and analog write. So this is an example in Arduino. Okay, so we have servo tester, and let's look into this LED map, how it will work. When we are on minimum position with servo tester, we are here. So now cabin backlight is off and proportional LED is off. And now we will go up with our servo tester. Let's look that now jet is going on, bright is changing to maximum, and cabin backlight is off because we are here in this range. And now we are going up with servo tester, and now cabin is on but jet is off. Why? Because we are here, we are exactly in this small range. Cabin is on and analog write or proportional LED is off. You can see it sometimes jet is blinking because there is no filtering now. So now we are in this position, and what will happen when we will go up with servo tester? Now we will control also proportional LED. So we are going up, and you can see that jet is going up, and in maximum position both are in maximum bright. Cabin is digital and is in maximum bright. Yes? So we are going low, and now we are in this range. So now we are controlling only jet, and when we go into this range, cabin backlight is on, and we also control jet. Simple? Simple. Okay, and now we want to control also landing reflectors. So not only proportional LED, not only cabin backlight two-state LED as we do before, but we want to add another switch SB, and with switch SB we will control landing reflectors. How to do it? We will use the same principle as before. So we will again divide these two ranges by 2. So we now will have 1, 2, 3, 4 ranges. And we will keep this mix as it was for SC, and SB we will divide this weight by 2. So for switch SB we will use weight 50%. So this is the map for digital LED. And for proportional LED we will again divide it into 2 ranges. So this will be our proportional LED. It will has offset 25%, half of this, and it will have weight 22%. Again, I use 3% in this example for this small range. So this will be our LED map. How to mix it? So when we go into HTX, our mix at channel 6. Again, this is our point 0, so this line means we are here. Switch SC is as it was before, weight 100%. Switch B now we have with weight 50%. And we will have for proportional LED for throttle, we will have half of this weight offset. So offset is 25%, it's half of 50. And weight will be 22%. Yes? So the same value as we have here. And how does this mix work? So when we go into channel monitor, we have all switches off, and now we are at 97%. Okay, so we are here. That's okay. 97%. Now SC, SB, both switches are off. This means that we are in this range now. So when I will go with throttle stick from minimum to maximum. We will go from minus 97% to minus 53%. So let's try. Minus 97%, and we are going to maximum minus 53%. Now switch SC and SB is off. Yes. So with throttle we are in this range, we are here. And now we will switch on switch SB. What does it mean? We will be here because switch SC is off. We will jump here. So what does it mean? Throttle mix will go from minus 47% to minus 3%. We will be here. So now we will switch on SB. So we are at minus 47%. It's okay. And with throttle we will go from minus 37 to minus 3. So let's test it. Throttle to maximum, and we are going to minus 3%. Okay? Please know that when I switch off SB, what we will do, testing question, I will switch off SB. When I will switch SB off, we will jump from here to here. So if throttle is on minimum, it will jump from minus 47% to minus 97%. Let's go. Now we are in minus 47. We will turn off switch SB, and we are here. So the mix is working. And now I will switch off SB and I will turn on switch FC switch. What will happen? Now we are at minus 97. So when we are here and I will turn on switch SC, I will jump from here to here because it has weight 100%. So 100, now we are in minus 97 plus 100, it means we will go to plus 3%. So let's switch SC on. SC on, we are at 3%. And what will happen when we will now go with throttle from minimum to maximum? Let's look into our LED map. Our LED map says that we will go from 3% to 47%. Let's check it. So now we are at 3% to 47%. Okay? So switch SC is on. We are going from 3% to 47% with throttle. And now we want also switch on switch SB. What will happen? Let's look into LED map. We will switch SB turn on. So we will go from this range. Here, switch SC is on, but switch SB is off. Here. And when we will switch SB go on, we will be in this range. So it means that throttle will go from 53% to 97%. So switch SB is on, we are 53% and we are going to maximum 97%. Is it clear? Okay, and now please know that we can use any combination of SB, SC and throttle. Yeah? It's easy. We have 3 independent channels. We are a single receiver channel. How to decode this with Arduino? So let's look into Arduino. This is example 3, Arduino. In Arduino, we will read pulse from receiver, and now if pulse value is more than 1500, if the pulse width is more than 1500, what does it mean? It means that cabin LED is on. So if it is higher, we will digital write cabin high and we will decrease input value, we will subtract 500 microseconds. Okay, so we will go from here to here, from this range to this range, minus 500 microseconds. And now, so we subtracted 500 microseconds, and now if the input value is higher than 1250, where are we? 1250, we are here. We are looking, are we in this interval? If yes, what does it mean? We will turn on landing reflector LED and we will subtract 250 microseconds. 250 microseconds mean that we jump from this range to this range. And what to do now? Now we will only map as it was before, proportional LED from this range to 0 to 255. So map PWM value from here to here. Again, I'm using 25 microseconds in this example for this small range. And now let's look into servo tester, how it will work. So we are connected to servo tester, and now let's look into LED map. Now we are with servo tester somewhere below this range. So everything is off. Cabin backlight is off, landing reflector is off, proportional LED is off. And now we will increase the value of servo tester, and what will happen? Let's look. Cabin backlight and landing reflector will be off, and we will increase the brightness of proportional LED. So let's go. We will go up, up, up. You can see now proportional LED is going up, 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 up to maximum brightness. And now landing reflectors are on. Why? Because we are in this small range here. We can see that landing reflectors are on, cabin backlight is off, and also proportional LED is off. And what will happen now when we will go up? Again, cabin will be off, landing reflectors will be on, and we will change the brightness of analog LED. So let's go up. And the brightness is going up, 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 and now we are here. Cabin is on. What does it mean? It means we are here in this small range. Cabin, we are above 1500 microseconds. Cabin backlight is on. Landing reflector is off. And jet is also off here. And now we will go up with servo tester. What will happen? Proportional LED brightness will go up, 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 up. Landing reflectors will still be off. Let's try it. So we are going up, 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 up. Brightness is going up. And now we came into this point. And now we can see cabin is on. Landing reflector is on. And proportional LED is off. We are here in this point. Cabin is on, landing reflector is on, but proportional LED is off. And what will now happen? We will go up with servo tester. Proportional LED brightness will be up, 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 will go up, 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 up. And at the end, everything will be at maximum brightness. Let's try. So we are going up, and you can see that jet is going up, and now everything is on. So this is how does this mixer work with servo tester. Let's see. Well, and now the last explanation for this video, how to add another channel and control not only proportional LED, not only cabin backlight, not only landing reflectors, but also how to control navigation lights. However, the video is long enough now, so this will be your homework. Let's think about how will looks LED map for this example. Let's think about how the mix in radio will looks. And also you can think about how the Arduino program will looks like, how it will work for this example. Of course, this is not everything you can do with this principle. You can add another channel and so on and so on. Yes, there are some limits, but I think you do understand what's the principle of operation of this light controller.